So, in the previous class, we discussed about computable functions and predicates. So, sometimes there is a need to represent the statements. There is a need to represent the statements in other way, or else we need to exempt some cases, right? So, in that case, we're going to uh, write the statement like this. For example, Paulus was a Roman and he never hated Caesar. So, but according to the previous given statements, um, all Romans. So the statement is all. See the fifth statement here. For that, I have written for all x, Roman of x, loyal to of x comma Caesar, or hate of x comma Caesar. That means a Roman may be either loyal to Caesar or either hated Caesar. That's it, right? Okay. So for that I have written for all x, Roman of x, loyal to of x comma Caesar, or hate of x comma Caesar. Okay, that's what I have written. Okay. Whereas here, a person called Paulus is to be exempted from this particular statement. So how to write that particular statement, right? So here, for example, that Paulus was a Roman and he never hates Caesar. That means uh, either he hates Caesar or either he uh, either he should be loyal to Caesar or he should hate Caesar. But here this particular Roman whose name is Pallas is to be exempted from the statement. So for that I have written like this: for all x, Roman of x, and not equal to of x comma Pallas. That means this particular Pallas has to be exempted. So that's why I have written Roman of x for all x, Roman of x, and not equal to of x comma Pallas, loyal to Caesar, loyal to x comma Caesar, or hate of x comma Caesar. So all Romans come under this except Pallas. Okay, so this one. So for example, and we can also represent these exceptions. So it becomes very easy to implement. When we have smaller number of statements. So like that, when I have smaller number of statements, I can represent like this, like the previous one. Okay, but whenever I have more statements, then it becomes difficult for me to represent it. So in that case, I need to represent it using either greater than or less than. Okay, so using greater than or less than relationships, I need to represent the well-formed formulas when I have large number of statements. So for smaller number of statements, I can represent like the previous one. But when I have more number of statements, then I need to represent it using either greater than or less than, right? Mr. 502, 19 series 502. Please mute yourself. Please see whether your mic is on or not. Please don't disturb the class. Right? So, when I have more number of statements, then I can represent using greater than or less than relationship. Okay. For example, see this one, greater than of 1 comma 0. That means 1 greater than 0. GT means greater than. GT of 1 comma 0 means 1 greater than 0. Next, LT of 0 comma 1 means 0 less than 1. Okay. Next, GT of 2 comma 1 means 2 greater than 1. LT of 1 comma 2 means 1 less than 2. Next, GT of 3 comma 2 means 3 greater than 2. Next, LT of 2 comma 3 means 2 less than 3, like that. Okay. Next. So if there are very large number of predicates like the above statements, we can easily represent them using greater than or less than relationship. Okay. So, but we need to have some additional knowledge while using those greater than or less than relationship, right? Next. So we can also infer new statements is smaller number by inferring the new statements from the older ones. That means using the older inferences or using the older using the older inference statements, I can infer new statements. So new statements can be inferred, or new statements uh, uh, new statements can be inferred using the old statements. Okay. Next. So Marcus was a man. I can write it as man of Marcus. Second one, Marcus was a Pompeian. So I can write it as Pompeian of Marcus. Third one, Marcus was born in 40 AD. Marcus was born in 40 AD. I can write it as born of Marcus, comma 40. Next, all men, so not means here, all men are mortal. I can write it as for all x, man of x, mortal of x. Next, fifth one, all Pompeians died when the volcano erupted in 79. So all Pompeians died when the volcano erupted in 79 AD. This is the statement. So I can write it as erupted of volcano, comma 79, and for all x, Pompeian of x died of x, comma 79. Here I have two formulas here. So I can divide these two well-formed formulas into two new statements or two new well-formed formulas. Okay. So now fifth statement will become this one. For all x, Pompeian of x died of x, comma 79. Okay. And next one will become erupted of volcano, comma 79. So I can make it I can make it as I can make this erupted of volcano, comma 79 as sixth statement. Sixth statement. Okay. Now seventh statement will become no mortal lives longer than 150 years. I can write it as for all x, for all t1, for all t2, mortal of x, and born of x, comma t1, and greater than of t2 minus t1, comma 150, dead of x, comma t2. Yeah. So next one, it is now 1991 AD. I can write it as now equal to 1991. Okay. Now a question was framed to me: is Marcus alive? So based on the previous statements, I need to search whether I can answer this particular question or not. But according to the knowledge I have using that is by using the above statements, I cannot answer this. I need some more knowledge or some other knowledge, or I need some additional knowledge in order to answer this question. So I need to write like this. So alive means not dead. If I write the statement, alive means not dead. No, alive means not dead means I can write it as for all x, for all t, alive of x, comma t means not dead of x, comma t. And not dead of x, comma t means alive of x, comma t. Okay. Next one. So, I represented like this. Next one. If someone dies, then he is dead at all other time, at all latter times. That means if someone is dead, I can say he is dead at all other times. That means at latter time, if I want to represent him, then he is dead. That means once dead means he's dead at every other at all latter times. Okay. Next. So I can represent it as for all x, for all t1, for all t2, died of x, comma t1, and greater than of t2, comma t1 means not dead of x, comma t2, like this. So now I can answer this question. Okay, now I can answer the question: is Marcus alive? Means as he is not greater than 150 years, and as it is now 1991 AD, and no mortal or no person will live longer than 150 years. So I can say that Marcus is not alive now. So based on the previous statements I have, I can answer this question now, right? So not alive of Marcus Gamma now. Now I need to prove this, whether Marcus is alive or not. So how to prove this one? So you have to see that while proving a particular thing, if no other statements are left to prove, there is no other statements are left to prove, or if you get nil statements, that means no other statement is remaining at last, then I can say a particular question, particular taken is correct. That means hence proved. That means, for example, if you take a theorem, and you need to prove that one, so you need to write some steps, right? So in that way only, you have to consider the answer, and you need to answer, and in order to answer the question, or in order to prove that particular answer, so if no statements are remaining to prove, then I can say that particular thing is proved. Okay, so see this one. So I'm considering the answer only. So not alive of Marcus comma now. Now I need to prove that Marcus is not alive. So I need to prove not alive of Marcus. Okay. Now, so not alive of Marcus comma now. Right. So not alive of Marcus comma now means. So I need to prove prove this. I need to prove this. But if no other statements are remaining at last, then I can say it is proved. Okay. So, uh, so I will share the screen to you once. Okay. Okay. Yeah. So see this one. Um, First one is Marcus was a man. Okay. So Marcus was a man, man of Marcus. Next, Marcus was a Pompeian, Pompeian of Marcus. Next, Marcus was born in 40 AD. So born of Marcus, comma 40. Next, all men are mortal. For all X, man of X implies mortal of X. Next, all Pompeians died when the volcano erupted in 79 AD. Now, erupted of volcano, comma 79, and for all X, Pompeian of X implies died of X, comma 79. Okay, next. So, no mortal lives longer than 150 years. For that, I have written for all X, for all T1, for all T2, mortal of X and born of X, comma T1 and greater than of T2 minus T1, comma 150 implies dead of X, comma T2. Next, it is now 1991. Now equal to 1991. Next, alive means not dead. For that, I have written for all X, for all T, alive of X, comma T implies not dead of X, comma T, and not dead of X, comma T means an alive of X, comma T. Next, if someone dies, then he is dead at all latter times. For that, I have written for all X, for all T1, for all T2, died of X, comma T1 and greater than of T2 minus T1 implies dead of X, comma T2. Okay. Next. Now these are some of the set of facts about Marcus. So here I have 9 statements only, but making it as 10 statements. Okay. Why means here I have got 2 things. In the fifth one. So all Pompeians died when the volcano erupted in 79 AD. Here I have got 2 things. One is erupted of volcano, comma 79 is one well-formed formula, and another one is for all X, Pompeian of X implies the head of X, comma 79. So I'm dividing it into 2 well-formed formulas, right? So so now I will get 10 statements or 10 set of facts. Okay. So man of Marcus, Pompeian of Marcus, born of Marcus, comma 40 for all X, man of X implies mortal of X. For all X, Pompeian of X implies dead of X, comma 79. So I'm just dividing it into 2 things. Erupted one thing, and for all X, Pompeian of X and another thing, right? So just written, I have divided it into 2 parts. For all X, Pompeian of X implies dead of X, comma 79. The sixth one is erupted of volcano, comma 79. Next one, for all X, for all T1, for all T2, mortal of X and born of X, comma T1 and greater than of T2 minus T1, comma 150 implies dead of X, comma T2. Right? Next. Now we equal to 1991. For all X, for all T, alive of X, comma T implies not dead of X, comma T, and not dead of X, comma T implies alive of X, comma T. Next, for all X, for all T1, for all T2, died of X, comma T1 and greater than of T2, comma T1 implies dead of X, comma T2. Okay. Just so here the numbering is changed slightly because sentence 5 has been split into 2 parts. I told you already, right? So fifth sentence has been split into 2 parts. That's why I got 10 statements here. Okay. Next. Now the question here is Marcus alive? Is Marcus alive? So the question can be answered by proving that not alive of Marcus, comma now. That means now it is 1991 AD. So and no mortal or no person lives more than 150 years. Means no person will live more than 150 years. That means below 150 years only. So that means maximum age or the maximum number of years a particular person lives or he's alive is only 150 years, max 150 years. Okay. So why I'm saying like that? Because uh, because of the seventh statement. That is, it is now 1991 AD. And the next, so sixth one, no mortal is longer than 150 years. That means no person is mortal. Mortal means who doesn't have death. Who doesn't have death is mortal. Okay. So no mortal is longer than 150 years. Okay. That means any person would live only for 150 years. Okay, that's it, right? Next. Okay, now a question framed to me is Marcus alive? So I know that Marcus come now, as it is now in 1991 AD, and Marcus has lived within the specified years, or is not more than 150 years. I can answer that he is not alive. That now I need to prove that one, whether he is alive or not. It is not. I'm saying that based on the previous statements, I can say that not alive of Marcus come now. I can say like that, but I need to prove that one. Not alive of Marcus come now is correct. Okay. Next. So I told you already that the term nil at the end of each proof. That means while proving anything, if I get nil statements or if I get nil, nil means no other statements are to be proved. It means or none state. If none of the statements is remaining to prove, then I will get nil. Okay. Then I can say that a particular proof has been proved. Okay. So the term nil at the end of each proof indicates that the list of conditions remaining to be proved is empty. The list of conditions remaining to be proved is empty. And so the proof has been succeeded. That means, so I don't know why some are disturbing the class. Please mute yourself. Okay. See this one. Not a level marks comma now. Now I have substituted ninth statement here. I have substituted ninth statement here. So ninth means this one. For all x, for all t, alive of x comma t implies not dead of x comma t, and not dead of x comma t means alive of x comma t. We substitute ninth one. I got this one. Which one? So dead of Marcus comma now. So dead of Marcus comma now. Okay. Dead of Marcus comma now. So not alive means dead. So I can write instead of not alive, I can write dead. So dead of Marcus comma now. So here x will become Marcus and t will become now. Okay. That's it. Right? So I can write not alive of Marcus comma now means I can write it as dead of Marcus comma now. Now if you substitute 10th statement. So 10th means this one. For all x, for all t1, for all t2, died of x comma t1 and greater than of t2 comma t1 implies dead of x comma t2. Okay. So here, so this one. So dead of Marcus comma now. Okay. So this one. Now I will get died of x comma t1 and greater than of t2 comma t1. So these two are remaining here. Okay. So now I will get of substituting 10th statement died of Marcus comma t1. Died of Marcus, x means Marcus, t1 means now. So died of x comma. So I don't know t1, right? I know only t. T means now. X means Marcus in the previous one. Okay. So died of Marcus comma now is there. Substitute 10th statement. Then I will get died of x. Died of x means I already know x value. It is Marcus. So died of Marcus comma t1 and greater than of now comma t1. Yeah, t2 means now, right? So why now or why t2 becomes now here? Because it implies to dead of x comma t2. So here dead of x comma 2 means x means Marcus, now means t2. Now I can substitute t2 value with now. Okay. So here these two, that is died of x comma t1 and greater than of t2 comma t1 implies dead of x comma t2. So I need to that means I already know what is the x value and what is t2 value, because substitute 10th statement, then I will get dead of in the place of x, I can write Marcus. So date of Marcus, comma T2 means instead of T2, I can write now. Okay, date of Marcus, comma now. So these two will be remaining now. So date of x, date of Marcus, comma T1, and greater than of um, greater than of now, comma T1. Okay. Yes. Right. So now I have to substitute where I have either died or greater than. Okay. Now see. Now if I substitute fifth one means what? So for all x, Pompeian of x implies date of x comma 79. It means I got died. So here died is there. So I can substitute died here. Okay. So if I substitute this one, substitute this one, um, died of Marcus comma 79. I'll get died of Marcus comma 79. Okay. So okay. So see this one. So here x comma t x comma so Marcus comma t1. So now will t1 will become 79 here. So t1 will become 79. So based on the previous statement, that is so based on the fifth well-formed formula or fifth statement, I can write died of x comma 79 means x means I already know Marcus. So now t1 will become 79 here. So I'll get now I'm going to write it as died of died of Marcus comma t1 is 79 after substitution. So I'll get Pompeian of Marcus. So Pompeian of Marcus and greater than of now comma 79. Why 79? Because instead of T1, I have substituted here 79. So now I'll get so greater than of now comma 79. Now after substitution of 2 substitutes 2 Pompeian of Marcus. Okay, so that is proved. So I need to prove this one. That means whatever I need to prove, that will be remaining. If any proof is there in the statement, then I can cross it over. Okay, ఏదైతే అక్కడ ఆల్రెడీ అక్కడ అంటే సబ్స్టిట్యూట్ చేయగా ఆ సబ్స్టిట్యూషన్ లో వాల్యూస్ వస్తే ఆ వాల్యూస్ ఇక్కడ రాసుకుని దాన్ని స్ట్రైక్ ఆఫ్ చేస్తాం. అంటే ఏంటి అక్కడ ఆల్రెడీ ఆ పర్టికులర్ స్టేట్మెంట్ తగ్గ స్టేట్మెంట్ కానీ దానికి తగ్గ వెల్ ఫార్మ్డ్ ఫార్ములా కానీ ఉంటే దాన్ని స్ట్రైక్ ఆఫ్ చేస్తాం. లేదు అంటే ఏదైతే ప్రూవ్ చేయలేమో అవి మాత్రం అక్కడ ఉంచుకోవాలి, దాన్ని ప్రూవ్ చేయడానికి ట్రై చేయాలి. ఓకేనా? సో ప్రూవ్ చేయాల్సినవన్నీ అక్కడ రిమైనింగ్ స్టేట్మెంట్స్ కింద రాసుకుంటాం. ఏవైతే ప్రూవ్ అయిపోతాయో, ప్రూవ్ అవ్వటం అంటే ఏంటి, అది ఆల్రెడీ అక్కడ ఉంటే డైరెక్ట్ గా దాన్ని అక్కడ రాసేసుకుంటాం. ఒకవేళ అక్కడ లేకపోతే అక్కడ పెట్టుకుని దాన్ని ప్రూవ్ చేయడానికి ట్రై చేయాలి. ఓకే, రైట్. నెక్స్ట్, సో నౌ Pompeian of Marcus is proved because I have second statement here, Pompeian of Marcus. So those two will be striked off. Pompeian of Marcus అనేది ఉంది కాబట్టి అది ప్రూవ్ అయినట్లు లెక్క. నెక్స్ట్, సో అది స్ట్రైక్ ఆఫ్ చేసేసి నెక్స్ట్ greater than of now comma 79, that is remaining. Now I need to prove this one, greater than of now comma 79, right? Next, now after substitution of eighth statement, after substitution of eighth statement, after substitution of eighth statement, I can write so now I need to have this one. So I need to search for greater than. So I have only one thing where I have greater than, this one, right? Okay. Okay. So here I have after substitution of eighth statement. Eighth means this one. So now we go to 1991. I got the value of now here. So instead of now, I can write 1991. So greater than of 1991 comma 79. Okay. Now I need to compute greater than function. Okay. Now compute greater than function. So if I compute greater than function, then I can get now greater than of 1991 comma 79 means 1991 greater than 79. It's proved. It's obviously proved now. So 1991 greater than 79. So it is proved. So no other statements is remaining. Okay. Or else I have another way to prove this one. I have another way to prove this one, right? So see this one. Okay. So this is another. So this is another way where I can prove. This is another way where I can prove. So not alive of Marcus comma now means after substitution of ninth statement, I got this one dead of Marcus comma now, same as the previous one. Okay. Next one, dead of Marcus comma now means after substitution of seventh statement. Instead of in the previous one, I have substituted 10th one. Here I am substituting 7th one. So 7th one means this one. Here it will become 8th now. Okay. So here 7 means this one. So so I have got 10 statements now. So now 7 means 8, 8 means 9, 9 means 10 here. Okay. So after substitution of 7th statement, I got this one. So dead of Marcus comma now. Dead of Marcus comma now. I got this one. Dead of Marcus comma now. Okay. Next one. Now I have to search for dead of Marcus comma now. Okay. So if I search for that one, in fourth one I have that one. In fourth one I have that one. So mortal. So not fourth one. It's seventh one, no? So seventh one means here. Seventh one. So seventh one means here. I'm going to get this one. Seventh one means here 6. It will become 6. Right. Seventh one means no mortal lives longer than 50 years. Okay. Because I have dead there. So that's why I'm substituting this one. So instead of in the previous one, I have substituted 10th one. Here I'm substituting 7th one. 7th one means here 6th. Because erupted of volcano 79 is 6th one. And next one will become no mortal lives longer than 150 years. Now I will substitute that one. I will get mortal of Marcus. So mortal of Marcus and born of Marcus comma, born of Marcus comma. I don't know that T1 value. So T1 is written like that one. So born of Marcus comma T1, born of Marcus comma T1 and greater than of I know the T2 value. So now minus T1 come 150. Okay. Now if I substitute fourth one, yeah, substitute fourth one. So fourth one means all men are mortal. That is, I got a mortal of Marcus. Okay. So mortal of Marcus is there. So mortal of Marcus is proved. Now only 2 will be remaining. Born of Marcus comma T1 and greater than of now minus T1 comma 150 are remaining there. Okay. Next. So mortal of Marcus. Marcus. So while substituting mortal of Marcus, I got another thing, that is a man of Marcus. Man of Marcus will be remaining. So man of Marcus and born of Marcus comma T1 and greater than of now minus T1 comma 150. Now I will substitute 1 here. Substitute 1 here. 1 means this one. Marcus was a man. This is man of Marcus. So man of Marcus and man of Marcus will get striked off. Okay. Now I'm going to get born of Marcus comma T1 and greater than of now minus T1 comma 150. Now I search for born and greater than symbols. Now if I substitute 3, 3 means here born of Marcus comma 40. Born of Marcus comma 40. Now T1 will become 40 here. Okay, born of Marcus comma T1 means if I substitute the 3, I'll get born of Marcus comma T1 value will become 40. Now if I substitute T1 for here, if I substitute T1 with now minus 40, come on 50. Okay, now I need to search for greater than of now. So now, so I know already know that now we go to 1991 according to eighth statement here. Here seventh. So it is now 1991 AD means now we got 1991. I know the value of now, right? So now can substitute it with 1991. So greater than of 1991 minus 40, come on 50. Now compute the greater than compute, now do computation. Yeah, compute minus. So greater than of 1991 minus 40 means 1951. 1951, come on 50. So greater than of 1951, come on 50 means 1951 is greater than 150. Okay, so get the GT of 1951, comma 150. Now compute greater than symbol. And 51 greater than 150. Yes, it is true. So now no other statement is remaining here. Now I can say that not a level of Marcus Kamenov is proved. Okay, that's it. So in this way, I can prove any of any of my answer by doing like this. So based on the previous statements, by considering the previous statements, I need to prove whatever proof I want. That can be proved by considering the previous statements. I need to do substitutions, and I need to prove that one, whether that is correct or not. Okay, that's it. Okay. So next, just I will introduce this one, resolution. So here resolution is a process. Resolution is a process or a procedure where I can prove the arguments which are expressible in predicate logic are correct. That means whatever arguments I express in the predicate logic, in order to prove that one as correct, I need some procedure. So this particular resolution is a procedure that is used in proving the arguments that are expressible in predicate logic are correct. That is, in order to prove the arguments in predicate logic as correct, I can use this procedure. So this particular resolution is first defined for propositional logic, but later it was extended to a predicate logic also. So this particular resolution process can also be applied to predicate logic and also propositional logic. So this particular procedure of resolution produces the proofs by refutation. So refutation is a process by which I can prove a particular argument as correct. Okay. So to prove the validity of a statement, this particular resolution procedure attempts to show that the negation of the statement produces a contradiction with the known statements. So whatever statements I know, if I consider the proof as negation, and if I prove that negation as a contradiction, means suppose for example, if consider this one, so not a level of Marcus Kamenov is there here. So not a level of Marcus Kamenov is there. That means, so if I consider as negation, that means negation of alive means alive. So I need to take alive of Marcus Kamenov, and I need to make it as a contradiction. That means alive of Marcus Kamenov is false. Alive of Marcus Kamenov is false means I can prove that not alive of Marcus Kamenov. That means considering the proof as negation, and at last I need to make it as a contradiction. Contradiction means false. Then I can prove it. Okay. So that is the process of resolution. Okay. Good. Here today 74 members are present today. Very good. With this, I'm stopping my class today. So I will continue the remaining topics in the next class. Okay, thank you.